This is all about orbitals. We're going to start with the name of a German scientist, Werner Heisenberg. A German physicist determined that it is impossible to accurately measure an object without disturbing it. And I want to give you an example that's actually mentioned in your book. It was a pretty good example, I thought. Nella is going to measure a balloon that is floating around this room in the pitch dark. Now, this room is not pitch dark, but imagine it is. Totally dark. She can't see a thing, okay? She wants to measure this balloon and she wants to get an accurate measurement of it. So it's totally dark. Guys, pay attention. This will go a lot better if I get some responses from you. That shows me you're paying attention. She's wandering around the dark like this, trying to find this balloon, and she bumps into it by touching it. Is she able to take an accurate measurement of the balloon and the direction it's going by touching it like that? No. So that's out. You can't touch a balloon. All right? She can't see anything. So she turns on the lights. What from the lights will be hitting the balloon and changing its path? Close. What do you call the particles that are emitted from light? Photons. You don't feel it, but there are literally photons coming from these lights. And the photons can hit the balloon and change its direction. That is tampering with the object. And so Heisenberg basically said, you cannot take an accurate measurement of an object without disturbing the object. And if you're disturbing the object, you're not taking an accurate measurement of it. When I was a kid, I used to watch all these nature shows. And I remember seeing this video of a male lion like Mufasa. He loses a fight to a younger, stronger male lion. And do you know the first thing a new male lion, a new king of the pride does when he defeats the former alpha male? You don't even know. It's kind of sad. Scar did it after he killed Mufasa. He tried to do it. He kills all the cubs that belong to that male because this new male takes over. He wants the bloodline of the male that he defeated to be gone. So it's really sad to see this new male chase down these little lion cubs and kill them. And I was a little kid, and I would scream at the TV because I was so scared. He got this male lion chasing down with just anger in his eyes, these little tiny cubs. And I asked my dad, why isn't the guy recording this helping? And my dad says, this is nature. You can't disturb it. If you want to accurately record nature, you cannot interrupt nature. This is why the people that are hiding in the bushes recording a zebra being eaten by a crocodile or a new male lion attacking all the cubs from the old male. You can't interfere or else you're not going to get an accurate measurement of nature. So this was known as the Heisenberg uncertainty principle. And this revelation of his was intended for electrons. You cannot accurately measure electrons unless you disturb them. And if you disturb them, you are not taking an accurate measurement of them. If I want to get an accurate measurement of like Madeline's daily life, I have to follow her and record it. Well, if she's being followed by me, she's not going to act normally. Like, this guy keeps following me. Then I'm not going to get an accurate representation of what her life is like on a normal day. So this was referred to as the Heisenberg uncertainty principle. This states that it's impossible to know precisely both the velocity, which is the physics word for speed, and position of a particle at the same time. David, if someone was asking your parents right now, where's David? What would they say? Okay, school, I assume playing high school. Do they know what building you're in right now? Do they know what classroom you're in right now? Do they know what desk you're in right now? But the best they can do is that you're in a general area of Tampa called Plant High School, right? But they don't know what building he's in. They don't know what room he is in. They don't know what seat he is in. The best they can do is like the general area. That's what Heisenberg said. We know the general area where an electron should be, but we don't know exactly, definitively, like its exact location. David's parents do not know his exact location. Plant High School is a lot of acres. So of all the universe, they've narrowed his location to Plant High. That's pretty good. But can you get more accurate than Plant High? I mean, you could, but you're not really able to if you want to accurately measure where he is. So what this basically states, guys, is that observations has its limits. And the region of an electron may be possible to know, but not its exact path. David's parents know he's at Plant High. They don't know what building, they don't know what room, they don't know what seat. So you cannot be completely accurate with where something is. You can know the area, but that's about as good as it gets. If you were to go to Armature tonight, you call your friends, yeah, I'm at Armature. Okay, where in Armature? It's like, I don't know. You can narrow it down to Armature, but that's about as good as it gets. You can narrow his location to Plant High School. That's about as good as it gets. When it comes to electrons now, done with David, done with Armature. When it comes to electrons, you know the general part of the atom where it should be located based on the energy level, but you don't know where in that energy level it's found. You don't know. That's the Heisenberg uncertainty principle. You don't know where it is for sure. All right. Moving on. Let's talk about the shapes of orbitals, the pathway that electrons take. And this is going to be a good pre-lesson for Monday, Tuesday, Wednesday. That lesson I told you is going to take you 3 days to really master. There are 4 sublevels in an orbital. And those sublevels are called S, P, D, and F sublevels. What you will hear me say, starting today, is sublevels may also be, the word sublevel can be replaced by the word block. S block, P block, D block, F block. S orbitals, or excuse me, the S sublevels are spherical. That's easy. P sublevels are dumbbell shaped. I'll draw them for you. It's like a figure 8. But then D and F are 3-dimensional and span in all directions. I really can't draw them. I could try, but it would be confusing. All right, so everybody, if you look back on the notes that we just did from lesson 3, how many quantums were there? Do you remember? There are 7. So let me show you this. You ready? I want to give you an example. You got 1s, 2s, 3s, 4s, 5s, 6s, 7s, okay? Check this out. 1s, 2s, 3s, 4s, 5s, 6s. Oop, that's ugly. 7s. 1, 2, 3, 4, 5, 6, 7. These are the s orbitals. They are spherically shaped. Now, if I really wanted to get messy with my drawings, I'm going to give it a shot. I'll show you what the p looks like. The p orbitals. And just to make sure I don't get too crazy with my drawings, I'm just going to do 3 levels, okay? I'll do, there is no such thing as 1p. You'll learn that starting Monday. There's 2p and there's 3p. There's no such thing as 1p. You'll learn that starting Monday. So here we go. This is going to get messy. All of that is 2p. These are 3p. These are the pathways that electrons take around the nucleus. So you can see how Niels Bohr really missed out on the nature of all the other electrons, because hydrogen just has 1 electron. It goes around in a circle. But all the other ones is crazy. And it is not like the planets in the solar system, unless you're talking about the S sublevel. But P looks like this, guys. It's like a figure 8 or a dumbbell. And if I can't even draw the D and the F ones, they're all over the place. But what I want to go over now, and I just kind of let that sink in for a sec. I got you for 5 more minutes. I want to show you how you can determine where these orbitals are on an actual periodic table, okay? So earlier I drew a periodic table. I told you that you did not have to draw it. Now I am going to ask you to draw it. So follow my lead, okay? Have each line on your paper represent a row. 1, 2, 3, 4, 5, 6, 7. Okay. Okay. I think that's decent. I then want you to do this. Like Olive pointed out, don't forget these down here. Okay. Next, use a different color. There's that. One, two, three, four, five, six. Okay. The middle is going to have 10 columns. You got to have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. The last one, it's going to have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I made a couple bulky rows at the end, but I think it'll work. Okay. What I need you guys to notice, the red ones, I have 2 columns. The purple area, I have 6. The green area, I have 10. And the blue area, I have 14. I'm going to break this all down for you. Actually, I think the bell is about to ring, so here's what we'll do. I'll pause it right here. And this will be, we'll consider this like a pre-lesson 5. Finish off today's class by making that diagram so that it is ready to go for us on Monday. Don't leave this room until you get that down. We'll pick up where we left off Monday, and this will be not a bad place to start me teaching you this new lesson. That'll take us 3 days, okay?